Este simposio trata sobre los targets clínicos y biología molecular en enfermedades renales y trasplantes, un tema apasionante, y tenemos 3 speakers de lujo para esta tarde. Y vamos a empezar la primera charla con el doctor Akalin. El doctor Akalin obtuvo su título médico en la Universidad de Ege en Turquía, y luego de hacer su Research Fellowship y su Clinical Fellowship en Boston, fue en los últimos años el director médico y del programa de trasplante de riñón y de riñón y páncreas en Montefiore Medical Center. Previo a esto había estado también con un título similar en Mount Sinai. Sus áreas de interés principales son los mecanismos de rechazo, tanto agudo como crónico, utilizando los métodos de biología molecular, de microarrays y monitoreo inmunológico, y por eso su charla va a estar dirigida al microscopio molecular en trasplante renal y el diagnóstico del rechazo humoral crónico. Dr. Akalin, it's a pleasure.
Good afternoon. Thank you very much for the introduction, and it was a kind invitation to attend to this meeting. And I would like to thank organizers and Rafael Maldonado. This is my first time in Argentina, so it's very exciting to be here, especially to be in Cordoba, because maybe some of you from Cordoba may know I worked for more than 10 years with Graciela de Bacardo. She was my partner as a transplant nephrologist at Mount Sinai as well as Albert Einstein. And also the following speaker, Valeria Mas, so we have collaboration and 2 NIH grants working together. So it's very nice to be in Cordoba to see their home town. So first I would like to start with the classification of the allograft pathology. As you know, it is called BAMF classification, started first in BAMF Canada, and then every 2 years pathologists, nephrologists meet to update the classification of the allograft pathology. Maybe some of you old enough to remember the old days that it was used term chronic allograft nephropathy, and the chronic allograft nephropathy hurt the transplantation because it gave the false impression that there is a disease like chronic allograft nephropathy without talking about it is immune-mediated, non-immune-mediated. Even the pharmaceutical companies did trials to change the immunosuppression without knowing what the etiology is, so it gave negative results, because if you minimize the immunosuppression in a chronic allograft injury due to immune-mediated mechanism, of course, then the patients will get worse. So it was first in 2005 meeting to get rid of the chronic allograft nephropathy and try to find out the exact etiology. I think the most important, is there any chronic antibody-mediated rejection, cellular rejection, recurrent or de novo glomerular disease, or here non-immune-mediated like BK virus nephropathy? If we cannot able to find any specific etiology, then we need to say it is IFTA, no evidence of etiology, maybe the old term chronic allograft nephropathy, but it pushes us to find the exact etiology. So this is one step. It started in 2005 to use the term of chronic antibody-mediated rejection, because since late 1990s, at least we have a test to see the footprint of the antibody-mediated rejection and the activation of the complement. It is just the same for these innocent bystander. The advantages is it binds covalently and stay there for a few weeks to months, depending on the treatment. It can be studied by immunofluorescence, or it can be immunoperoxidase method, and it becomes the major biomarker and introduced as the standard of the treatment, a standard of the diagnosis. So after the C4D, of course, then we can use the diagnostic criteria for the rejection. that there should be, of course, serologic evidence of antibody. And at the beginning, it should be C4D, but diffuse, peritubular capillary, more than 50%. And also allograft pathology like transplant glomerulopathy, laminated basement membrane multi-layering. And unfortunately, nothing much happened in chronic T-cell mediated rejection, only chronic allograft arteriopathy. And if there is donor-specific antibody, this will be a part of antibody-mediated rejection. So there is ignorance of the chronic T-cell mediated rejection according to the BAM classification. So just to show you here the transplant glomerulopathy, you appreciate here very nicely the application of the glomerular basement membrane. It looks like MPGM, but there shouldn't be any electron dense deposits, or there shouldn't be any hemofluorescent positivity. Otherwise, you cannot use the term transplant glomerulopathy. Here you see the multi-layering, and also this is the chronic allograft arteriopathy with lymphocyte infiltrates. So I think the question rises, okay, it is diffuse C4D more than 50%. What about if it is focal, between 10 to 50%, or minimal C4D? So that at that time we didn't know. And then we look at it at our series when I was at Mount Sinai with the transplant glomerulopathy, and we have 36 patients, but we found out that only 15% C4D positive and 36% has donor-specific antibody. So it is under chronic antibody-mediated rejection, but our experience, we cannot document C4D, we cannot document donor-specific antibody. So it raised the question to us, what we should do further to identify. So the other problem is that even the kidney biopsy is gold standard, but in reality, it is not really the gold standard treatment. Because look at it, that the agreement between two pathologists is 10 to 50%, on lesion scoring, diagnosis 40 to 70%. I know there are some pathologists I appreciate their contribution, but even they asked to review the slide, and then 6 months later, they did it again, so they agree with themselves 70 to 80% of the time. And there are a lot of non-specific changes, and we cannot read the exact diagnosis, especially for non-specific scoring, and we don't know what to do. Is it immune-mediated or non-immune-mediated? So this is very interesting. So this is the study that these are the best, most experienced transplant centers. And they sent the same slides to all the centers, and then they run the C4D staining with immunohistochemistry, and then they compare their result. And the agreement, the kappa value is 0.16. So this raises the question how we can compare our results with each other. Because even at the best hands, still the same material done by each pathology centers, and it comes with the agreement is very low. So this is why, like compared to conventional, what is the molecular microscope? So by saying the molecular microscope, it is used by the Affymetrix, and it is not like electron microscope. Molecular microscope means the gene expression profile of the biopsy samples. So it was started with the Edmonton Phil Halloran group, so they started to look at the gene expression profile, and I think it's a smart way to look at it, what they call pathogenesis-based transcript. Because in gene expression profile with the Affymetrix, you will get 30,000 gene transcript. So if you look at one by one, it would be very difficult to reach a meaningful conclusion. And with this method, what are the main players we have? Cytotoxic T cell, regulatory T cell, B cell, natural killer cell, and then rejection-associated transcript. So they found out, based on the animal models as well as the human biopsy samples, they created pathogenesis-based transcript. And especially that they look at the antibody-mediated rejection, and they call DSA, donor-specific, antibody-specific transcripts seen in antibody-mediated rejection. And these are 23 gene transcripts. And it is mainly associated with the 3 interferon gamma associated, natural killer cell associated, and endothelial cell associated transcripts. So this is very specific for molecular microscopic diagnosis of the antibody-mediated rejection. And here, based on the cytotoxic T cell macrophages, rejection-associated transcript, or parenchymal transcripts that do less means that more irreversible. So the diagnosis will be T cell mediated, antibody-mediated rejection, or acute kidney injury, as well as the irreversible findings. And after that, they tried to score based on almost more than 1,000 samples, based on this pathogenesis-based transcript. They score, if it is higher than 0.2, the higher it is, the more likely antibody-mediated rejection. And so it gives the score of antibody-mediated rejection, as well as the same for T-cell-mediated rejection, if it is more than 0.1 cutoff, and it is significantly associated, of course, in rejection, tubulitis, interstitial inflammation, and vasculitis. So this is the molecular microscope diagnostic system, how the system gives the rejection score, T-cell mediated, antibody-mediated rejection, atrophy, and scoring, and acute kidney injury. So this is we involved also in field Halloran study from the Canada, United States, and Europe. Still here you cannot read it, it is very, but the agreement is around 76%. So 76% of the time, the histopathology and molecular microscope agrees with each other. Of course, none of the methods are perfect, so it would be better to evaluate the molecular microscope result with the histopathology to reach a more meaningful conclusion to help the diagnosis as well as the treatment of the patient. So I will talk a little bit about our experience at Albert Einstein Montefiore. And the last 10 years we started to collect the samples. So we have at the moment almost 500 patients right now, 100 at the time of surgery and 400 patients at the time of clinically indicated biopsy. So when we get the sample of the biopsy, at the same time we get serum for the antibodies and one tube for the RNA PEG-CHAN tube to do the blood gene expression profile, and we have the one tube for DNA PEG-CHAN. We haven't done it yet, but in the future plan to do the DNA is genome-wide association that you heard yesterday from Dr. Garabi, and also we collected the urine sediment and supernatant as well. So the first question was we had, why only the diffuse C4D? What about the minimal or focal C4D staining? Or we see significant glomerular C4D staining. So what is the clinical and histopathologic meaning? So again, you cannot read it well, but the isolated glomerular, it was significant, like the 70 patients. And in terms of serologically, there was no difference in terms of C4D, like the PRA, DSA, histopathologic diagnosis not related to the rejection, and then there is no statistical significance, the bound allogram injury score. But even the minimal or the focal, both has higher PRA, higher donor-specific antibody, higher mean fluorescent intensity values, and then mostly related to the acute and chronic antibody-mediated rejection, as well as the transplant glomerulopathy. And when we look at the molecularly, and again, there was no difference whether it is minimal, focal, or diffuse staining. But if we look at the focal C4d and then the minimal C4d, significant increase in interferon gamma and rejection cytotoxic T cell, as well as some with endothelial associated. But the glomerular pathology, if it is glomerular C4d staining, molecularly it was silent. There was no findings of the rejection as well. So at this study we concluded that the minimal peritubular capillary C4d is associated with antibody-mediated rejection, but the isolated glomerular C4d was not associated. So the next question was, what are we going to do with transplant glomerulopathy? Because our patient population, the majority, they do not have C4d or donor-specific antibody. So at that time, we hypothesized that if the DSA positive, whether C4d positive or negative, probably it is chronic antibody-mediated rejection. But if it is both donor-specific antibody negative, C4d antibody negative, with some inflammation, it could be due to chronic T-cell mediated rejection. So we have like 18 antibody-mediated rejection, because at that time, we can only, because there was no microvascular inflammation at that time, DSA positive, C4d positive, and we have transplant glomerulopathy, DSA positive, C4d negative, but also we have DSA negative, C4d negative. So 3 groups of transplant glomerulopathy compared to the IFTA without any DSA or the C4d. And especially the G-score, whether there is DSA or C4d, just being the transplant glomerulopathy, significant increase. But the peritubular capillary is more associated with the antibody-mediated rejection, peritubular capillaritis, seen in DSA positive. And again, of course, they have higher microvascular inflammation score. So it's a busy slide, but just take a look at DSA negative TGP. The only molecular significance is whether it is compared to normal or IFTA, is the cytotoxic T-cell gene expression. But there was no increase in donor-specific antibody, which is the antibody-mediated rejection. So here, whether if it is DSA positive, whether C4d positive or C4d negative, it doesn't matter. So they have the similar gene expression patterns and molecular antibody-mediated rejection. So this is why after this study, we said that transplant glomerulopathy is an end organ damage. Probably at least 50–60% develop through the antibody-mediated rejection, but some are through the T-cell mediated rejection, just the glomerular antigens that the T-cells are synthesized and probably creating the allograft injury. So the next question, how we can diagnose the antibody-mediated rejection without the C4d? So this is also from Phil Halloran's group. So this is glomerulitis and peritubular capillaritis. Of course, it is classified 1, 2, 3, mild, moderate, and significant glomerulitis and the peritubular capillaritis. Of course, the maximum score will be 6. And if the higher the microvascular inflammation, more number of the donor-specific antibodies. So we ask ourselves that what are the molecular evaluation of the different scores of microvascular inflammation. So here you see, for example, the peritubular capillaritis, if it should be between 2 to 5, and this is, for example, 5 to 10, 2, and more than 10, 3, so you see more than 10. So this is, for example, peritubular capillaritis 3. This is also significant glomerulitis. The score is 3. So we look at it, we have microvascular inflammation 0, 59%, 19% 1, and 22% more than 1. And we have also some of those patients, almost 60 to 70, has the molecular findings as well. So when we look at the higher the microvascular inflammation, 2 or higher, has more donor-specific antibody. compared to microvascular inflammation 1 and 0, the higher the MFI values of the donor-specific antibody. And when we look at it in terms of the diagnosis, the 80% is immune-mediated, whether it is acute antibody or T-cell-mediated rejection, and chronic antibody-mediated rejection, or transplant glomerulopathy. So the question was, again, not easy to see at this slide, but compared to microvascular inflammation 1 to 2 or higher, if it is microvascular inflammation 2, higher, the cytotoxic T-cell, interferon gamma, and rejection, and especially donor-specific antibody, this 23 gene transcript significant upregulated. But when you look at the microvascular inflammation score 1, only cytotoxic T-cell. The other thing, the endothelial associated transcript, this is 110% gene transcript, and according to our study, it doesn't come always a good marker as compared to DSASD, donor-specific antibody. So we said, okay, let's further divide 1, 2, or 3. So it doesn't matter whether it is the microvascular inflammation 2 or 3, still the gene expression pattern was associated with antibody-mediated rejection. And we look at it also, microvascular inflammation 2, DSA positive or negative, whether there is no DSA, still the pattern was the DSASD, antibody-mediated rejection. And also, at that time, it wasn't read as histopathologic antibody-mediated rejection, but we look at it, microvascular inflammation 2, C4D negative, and again, the molecular group, it was antibody-mediated rejection. So we concluded that the microvascular inflammation score 2 or higher is significantly associated with the histologic diagnosis of acute and chronic antibody-mediated rejection, supports the classification of the BAMF-C4D negative antibody-mediated, and also especially the DSASD gene transcript could be used as a molecular marker for antibody-mediated rejection. And especially, we know the C4D positive, there is an activation of the complement, and then C5 to 9, and then the injury. But in C4D negative, it is through the interferon gamma effects, endothelial activation, leukocyte recruitment, FC receptors, leading to glomerulitis and peritubular capillaritis. So at that time, they asked us the question, okay, there is no, because we look at it at the published paper, the DSA positive and negative, so they raised the question that there is no DSA, but we only look at the anti-HLA antibodies through the Luminex single antigen means. Maybe there are non-HLA antibodies and there's an antibody because you didn't study. And then the vice, well, you have patients, donor-specific antibody positive, but the creatinine is good, no proteinuria, you do the biopsy. So how donor-specific antibody positive, you just reached the conclusion without looking further that this is an antibody-mediated rejection. So then we look at it, that it was just published last month, and we look at it, we didn't pay attention to DSA. Okay, let's take a look at the microvascular inflammation, positive and negative. So there were 100 transplant glomerulopathy, 51 microvascular inflammation negative, and 49 negative, 51 positive. And especially the microvascular inflammation positive ones had slightly higher interstitial inflammation score. So how they did it? So if it is microvascular inflammation positive or negative, whether there is DSA positive or negative, there was no difference. But if we look at it, microvascular inflammation positive compared to negative, those patients have the lower allograft survival. And also, we look at it, microvascular inflammation positive to negative without looking at the donor-specific antibody, microvascular inflammation is associated also cytotoxic T cell, natural killer cell, B cells, as well as the DSASD, molecular antibody-mediated rejection. But if there is DSA positive but no microvascular inflammation, then we didn't see the molecular pattern of the antibody-mediated rejection. So we concluded that the prognosis of transplant glomerulopathy is poor, definitely, whether it is DSA or NDI score, but is significantly worse in the presence of microvascular inflammation. And again, the same. If it is microvascular inflammation, positive antibody-mediated rejection, but if it is negative, it is T-cell mediated rejection, just a cytotoxic T-cell. So this is why in the updated BAM classification, the NEC4D 1, 2, 3, or microvascular inflammation 2 or higher, or the molecular findings, of course, again, it is not the standard of the care, but it is available right now in the United States to use the molecular microscope. So and that initial BAM classification removed, so they don't use the term ANDA, so it is more DSAST or the molecular microscope score of greater than 0.2. So these are the good things right now, the helping the molecular microscope. But we need to be careful, and what are the problems still we have to use in clinical practice. So one is the genomics of BK virus, viremia and nephropathy that we look at it. So if the patient has BK virus nephropathy, and they have, when we look at the gene expression pattern, they look like rejection. T-cell, natural killer cells, almost like the T-cell and combined mixed rejection, antibody-mediated rejection pattern, because in rejection, T-cells are primed and activated to the alloantigens, but in the BK virus nephropathy, through the viral antigens. So in terms of, it is very difficult to diagnose the BK virus nephropathy because the result will be like the rejection. So what you need to do is, of course, it is easy to use to diagnose BK virus nephropathy histopathologically with SV40 staining. So this is how you will differentiate and careful about the molecular assessment. And look at it like in the blood, BK virus viremia, and they have cytotoxic T-cell and natural killer cell activation in the blood. But there was nothing before the development, and the patient we monitor as well. When the viremia disappeared, it became negative as well. So this is one thing you need to be careful. And it is located with the gene ontology, BK virus nephropathy, everything is related to immune activity. So the other is the glomerular disease. So we have not published yet. We presented last year at American Transplant Congress as well as American Society of Nephrology. We had 83 kidney biopsy samples, 33 transplant glomerulopathy, 10 membranous nephropathy, 60 secondary FSGS, 6 primary FSGS, and we compare with the normal transplant kidney biopsies. So when you look at it, there is a significant overlap with transplant glomerulopathy, especially with the primary FSGS. And when we look at by engaging pathways, this is done by Valeria Mas, and you will see here that there is a significant overlap between transplant glomerulopathy and primary and secondary FSGS. The membranous is still a little bit more silent, not much, but the FSGS definitely significant immune activity. There are like a few pathways just seen in the primary FSGS and some transplant glomerulopathy, but especially primary FSGS and transplant glomerulopathy share so much molecular. So this is the other problem as well. If you send the glomerulonephritis, again, the result may come as rejection. But of course, you will have better diagnosis by using immunohistopathology electron microscope and immunofluorescence for the glomerulonephritis. So this is one problem. Because the molecular microscope is mainly based on the pathogenesis-based transcript. So we look at it as well with the pathogenesis-based transcript. Look at the primary FSGS, everything from endothelial cell-associated interferon domain rejection, cytotoxic T cell, B cell, natural killer cell. The only thing is that still the DSAST is only in transplant glomerulopathy, but all the others, the vigorous immune response in primary FSGS. So these are the initial results because these are not published and nobody look at the molecular examination of the recurrent or de novo glomerular disease. And again, we look at it the first inherited pathways, pathogenesis-based transcript, and also we look at it by the gene ontology, glomerular disease. Look at everything is related to the lymphocyte activation, T cell, a B cell, natural killer cell. So we concluded that the gene ontology analysis that all for glomerular disease increase expression of gene transcript related to activation, regulation, and differentiation of T cell, B cell, leukocytes, cytokines, chemokines, and inherited pathways, again, significant overlap. And especially the membranous was least aggressive in terms of gene expression, followed by secondary FSGS, but primary FSGS and transplant glomerulopathy has the most differentially expressed genes. It's still a small numbers, but in primary FSGS, this interleukin signaling and IL-9 signaling pathway were uniquely activated. So the last slide, just briefly in terms of the take-home points. Molecular microscope helps in diagnosis and confirmation of antibody-mediated rejection, whether by DSAST or antibody-mediated rejection score greater than 0.2. If this will help, especially like if you do not have the donor-specific antibody, because it is not just the HLA, but molecularly, this is the most helpful in terms of the diagnosis. The other is the, again, there is a donor-specific antibody positive, but the molecularly silent, then you may say that this patient doesn't have antibody-mediated rejection. I think this will be the most important message. Again, the other important is transplant glomerulopathy is an end organ damage through different etiologies. The majority from antibody-mediated rejection, but still the NBI and DSA negative has the molecular features of T-cell mediated rejection, and still at the BAM classification that I have been attending and discussing since 2005. So finally at the last BAM classification, they said that transplant glomerulopathy is multifactorial, can be due to mechanism included the chronic rejection and hepatitis C virus, but still they didn't put under the chronic T-cell mediated rejection. And we need to be very careful, especially with glomerular disease and BK virus nephropathy. There is significant overlap molecularly. So of course, I would like to thank the UBA, our research technicians helped to create the biobank. It is very important that we have very good tissue typing, pathologists, and these are mainly done also with the Albert Einstein computational genomics facility, and then some part, the glomerular disease, the Valeria has significant help, and collaboration with Phil and Halora, and by the NIH studies. Of course, the transplant nephrologists and surgeons help to create the biobank to collect the samples. Thank you very much for your attention.
Bueno, muchísimas gracias, doctor